In this lesson, we're going to look at why completed in square form is useful in terms of quadratics. Now, in Unit 1 and in the last lesson, you were shown quadratics in completed square form. This is where you've got a bracket and a squared, and you've got a plus or minus value. Not always a plus or minus value, but usually. Now, the point in this is to identify the turning point of the quadratic. Now, some of you might be thinking, what is a turning point? We'll look up at the title bar here. The turning point is where the graph starts to turn, so you can see it happens down at the bottom here. This is called a minimum turning point because it's going down to a minimum value and then back up the other side. So this point here would be the minimum turning point. If we look over at this graph here, this has not got a minimum turning point, this is going up to a maximum. The maximum turning point is up at the top here, that's where the y value is its maximum value. And I suppose over here it's where the y value has its lowest value here for the minimum turning point. Now you might think, why is it easy to see that from this? Well, I'll show you very quickly down here and then I'll explain it in more detail. So if you're asked to identify the turning point of this quadratic here, this is a minimum turning point because it's a plus x squared. The answer to this is just 3, 4, just from looking at it. Again, I'll explain this in the next slide. And this one would be -2, -6. So how is this so easy to do? Well, let's have a wee look. So imagine I was asked to sketch this graph. We'll do that in the next lesson, but imagine I was asked to do it and I wanted to work out where the turning point was. Well, the turning point happens when the y value is at its smallest. This is a minimum turning point we're looking at here. It would be a plus x squared if you times all this out. So it would be a minimum turning point. Now, the smallest value that this can take is when this side is at its smallest. Now, what we kind of have to focus on here is this part here. What is the smallest value this can take? Now, because it's a squared function, when you square a number, even when it's negative, it turns to positive. So the smallest value that this here can take is 0. Because when you put a number in for x and you square it, you'll never get a number below 0. So we're looking for an x value that gives the smallest bit for this green oval. And that would be 3. Because 3 take away 3 would be 0. So we're trying to make this bit 0. That would be an x value of 3. And if you make this bit 0 plus 2, then your y value is just 2, because it's 0 plus 2. So your turning point happens when x is 3. So it's at 3, 2. So that's where it would be. It would be a minimum turning point at 3, 2. Now I've said here, can you find a y value smaller than 2? Well, you can put any value of x in you like, but I guarantee you won't get a y value smaller than 2. Even if you put negative in, -1, take away 3, that's -4. Square it, 16 plus 2. So the smallest value this can take is 2, and that's where the minimum turning point's at. Now, I'm going to go through all these answers quickly. You can pause the video and then try them yourself, see if you understand, and then I'm going to go through the answers. Okay, so if you've paused the video, here's the answers. So in each case, what you're trying to do is you're trying to make the bracket bit 0. That would be this bit here. So the turning point here would happen at 4. X is 4, and that would leave you with a 1. So the turning point would be 4, 1. This one, you're trying to make this bit 0. So the turning point would happen at 2, and that would leave you 0 here, and then 5. So 2, 5. This one, the turning point would happen at 1, 7. Okay, over here, turning point would happen at 2, -3. Okay, next one, turning point would happen at 3, -4. Next one, turning point would happen at 5, -2. Okay, part G, the turning point would happen at minus 4, 6. Turning point would happen at minus 1, 5. Turning point would happen at minus 8, 1. Turning point, minus 3, minus 1. A wee bit different. Minus a half would make that 0. So it would be minus a half, minus 3/4. Minus a half, minus 2.5. Don't worry about the negative sign here. You're still trying to make this bit 0. So that would be 1, 4. Minus 6, 3. Minus 7, minus 2. It doesn't matter the x is the end here. It would be 2, 12. 5 minus 1. Lastly, 4, 3.75.